In this video, we're going to cover the free response on page 12 after the multiple choice. That is 2004 Form B free response. Also, if you have any questions over the multiple choice, I try to write out explanations, but feel free to join in the Zoom, or if the Zoom time doesn't work for you, let me know. We can find another time to talk about those. But I want to focus more on free response now, since we know that's what your test is. But the reasoning and the multiple choice will still be beneficial. So in this problem, this is a calculator question. So I was hoping by now y'all noticed if it's a 1 or a 2, that means you can use your calculator. Also, I did hear that technically every free response, since you're doing it at home, is considered calculator. Now, it might not be helpful, but we will need the calculator. So if you don't have a calculator, you can do most of this online. If you need a graph, I would use Desmos. If you need to do a definite integral, you can find that online as well. Just type in definite integral calculator. So what's going on here? It says for the time 0 to 31, the rate of change of the number of mosquitoes on a tropical island at time t days is modeled by R of t. And notice this is mosquitoes per day. This is a rate function. This is like a f prime of x function. And there were 1,000 mosquitoes at time t equals 0, so they give you an initial condition. How many mosquitoes you're starting with. So it says, show the number of mosquitoes is increasing at time equals 6. So notice this is just number of mosquitoes, which is like your f of x. How do we know when f of x, if it's just amount, that's f of x. How do we know when f of x is increasing? Well, if the derivative, which is what they give you, mosquitoes per day, is positive at that point. So what we want to see is we want to show that f prime of x is positive at t equals 6, which f prime is your r of t. So if you prefer keeping it f prime, f double prime, you need to define somewhere on your paper that f prime of x equals r of t. Okay, if you define that, then you can start referring to r of t as f prime, but if you never write that down, you're going to get it wrong. Or if you're comfortable with different notation, I would just use r of t. So we want to show that f prime is positive, which just means we want to show that r of 6 is positive. So you just plug it in, 5 times the square root of 6 times cosine of 6 divided by 5. And you have your calculator, so you type that in, which, hold on, we are going to use that in a second. That's the graph. But on the next page, I typed it in, and it's 4.437. Or you can round that up to 8. But if you go 3 numbers after the decimal, you can do either. And we can see that that's a positive number. So the number of mosquitoes, I would just use the words they use instead of trying to use like f. Sorry, I looked weird for a second. Is increasing because r of 6 is positive. And you would want to make sure you actually write down that number so they know you checked it. Okay, so part B says at time t equals 6, which is what we just talked about, the number of mosquitoes increasing at an increasing rate, or is the number of mosquitoes increasing at a decreasing rate? Give your answer. So we just determined it's increasing, but now we're trying to determine, is it increasing at an increasing rate or increasing at a decreasing rate? So when it's worded like that, really what that is the concavity of the original graph, right? Saying increasing at an increasing rate would, if it's at an increasing rate, that would be concave up. And if it's increasing at a decreasing rate, that decreasing rate means concave down. So So we're trying to determine, is our original function concave up or concave down? Well, how do you know based on the derivative function? Is r of t increasing or decreasing? Right? This would just determine, is it positive or negative. Now we want to show that r of t, which you could write f prime if you defined it as r of t, is increasing or decreasing at t equals 6. So you could do this a number of ways. I think to get the full credit on this for your response, you had to consider, so how do you know? Normally what you do is you take the second derivative and you see if it's positive or negative, right? So what would this is like your first derivative, it's your f prime. So then we would be looking at the derivative of that. To know if r of t is increasing or decreasing, we want to know, is its slope positive or negative? Right? Isn't that the same thing? To know if it's increasing, then the slope, the derivative is positive. If it's decreasing, r prime, the slope would be negative. So we want to know what r prime of 6 is, ultimately. So I'm going to show you a trick on the Inspire. Some of y'all figured it out, which is good. But I was going to wait to show y'all this till we reviewed, and now that I'm not with y'all, it's kind of weird. But you could use product rule and probably do that, but that would be a lot of work and a lot of time, especially when you have a calculator. So one thing you could do is look at your graph at 6. Now you could change your windows and see, and you could literally just look, is this r prime graph increasing or decreasing? And you should know the answer. But to get full credit, you had to consider this number. That's what it says, is considers r prime of 6 as a point. So how do we know r prime of 6? Oops. I'm just zooming out a lot. I don't know why. It won't stop. Okay. Is instead of doing it ourselves and doing product rule, you can go to Menu, Calculus, Numerical Derivative at a Point, keep your variable x. We want to know at 6, so this only works if you're evaluating at a point. If you actually need the derivative function, this doesn't help you. And we're going to just do the first derivative, and then we're going to type in that function that we're taking the derivative of. So that was 5 times the square root of x, go out of your square root, times cosine of x divided by 5, and make sure it's in radian mode. Push enter, and it's negative 1.913. So now we can see that r prime is negative, so that means r of t will be decreasing, which means it's increasing at a decreasing rate. Or you can think about it as your function is concave down. So that's what I'm going to say. The number of mosquitoes is increasing at a decreasing rate because r prime of 6 is negative. And that is B. So they kind of have a similar format, but here you were just worried about r of 6. Here you're worried about r prime of 6. C is, according to the model, how many mosquitoes will be on the island at time t equals 31. So this kind of goes more into chapter 4. You should know how to do this one by now. So how many mosquitoes at the end of a time period? You just always take the same format. To know the number of mosquitoes, you got to take the initial amount, which was 1,000, plus, now to know the total amount that accumulate, that's when you integrate. When they give you mosquitoes per day and you want to know how many mosquitoes, you're going backwards. Integrating from 0 to our time of 31, if you integrate your RT function, it'll get you the net change in mosquitoes over time. How many mosquitoes accumulated from 0 to 31. And you just type that in your calculator. to review on the calculator, it would be 1,000 plus, so that should not be inside the integral. Menu, calculus, numerical interval from 0 to 31, and then you type in your function, so 5 times the square root of x times cosine of x divided by 5 dx. And it's 964.335. Mosquitoes would be your units. And then does it say to round it? Round to the nearest whole number, L. So I should have actually said, what if you round that? It would be 964 mosquitoes. I don't know if they would take off if you forgot to do that, but I should read instructions. Okay, so for the last part, it says, to the nearest whole number, what is the maximum number of mosquitoes for your closed interval? So we're looking for an absolute maximum on an interval. So to find an absolute max on interval, how do you do that? You first find critical numbers, which is when, oops, I'm going to put that in parentheses, when f prime of x equals 0, or technically undefined if that applies. And then you test your critical numbers and your endpoints. And what do you plug those into? For absolute maximum, if you're not doing a sign chart, you plug them into the original f of x. Original. And you just see if it's maximum, which one's the largest, if it's minimum, which one's the smallest. Okay, so this is kind of a lot, but you have a calculator, so it helps. So to first find your critical numbers. We're going to take when what is it? What is the max number of mosquitoes? So you have to think about this. If we're talking about number of mosquitoes, then what is the derivative? Because we want to set f prime. That is your r of x. So you're not going to go take r prime. We're talking about number of mosquitoes, which is f of x. So its derivative is r of t. So we're going to take r of t and set it equal to 0. And so now to know when r of t equals 0, because if we think about it, that's when 5 times the square root of x times cosine of x over 5 equals 0. And to know that, you would need to graph and get the x-intercepts. Which Desmos is very beneficial. And make sure you look at for the whole interval, get all the x-intercepts from 0 to 31. So, if you're doing it on a calculator, here's my graph. Now I messed up my window because I don't know what just happened earlier, but I can go change my window to be from 0 to 31, and I could change my, you don't necessarily have to change these. I'm not sure if this is going to be necessary or not. Okay, so I can see that there are two x-intercepts, two critical values. So I'm going to find those. Again, if you're using Desmos, you can just click on them. Nope, that's not what I want. 6, 0, click on the lower bound, click on shade up. So it's 7.85 is the first one. And the other one is 23.6. So when I make my table to plug them in, I have 7.85, 23.6, and then I have my endpoints, my interval. It went from 0 to 31. So I have 4 numbers to plug into the original. This doesn't look like an 8. So do I have my original? So that is not, you should not, whatever you set equal to 0, you should not be using down here, because this is technically the derivative. If they give you a derivative function and you're looking for the original, what would you do? You would integrate, right? But now you cannot forget to add that initial amount. So actually I'm kind of going out of order, because I actually did another pre-response before this one. And so I wrote this down on another video, which you'll get to. But if when given f prime and you need f of x, it's this format. So I'm trying to make sure you don't look at the rest of this so you see that when you do the video. But you have to integrate the derivative, but then you have to add that initial amount. This is your format. If they ever give you f prime but you need to write down f of x, you need to memorize this. Okay, f of x equals the initial amount plus the integral from the x value that goes with that initial amount. You keep that x so you can plug in whatever x value, and then of f prime of t, if you keep that f prime of x, they wouldn't take off. That part's not as important. So we're going to use that setup. In this case, our f of x is going to equal, what is our initial amount? How many mosquitoes? 1,000. And then you add the integral. What is that? What is the x value that goes with that? The time was 0. So any given other x value of your derivative, which was r of t. And so this will give you the amount of mosquitoes at any given time x. So for 7.85, you're going to do 1,000 plus the integral from 0 to 7.85 of r of t dt. So you're going to use your calculator, and it's going to go faster than you think. If I can get out of the graph. Because I'm just going to use this same format, right? So if you've already typed this in from C, you don't need to retype it in. You can just scroll up, highlight, and then all you're changing is that top boundary, right? Everything else is staying the same. You are not, notice, I'm not plugging for these x's. You need to leave that an equation. It needs to be dx. There should be x's in there. That's why we changed it to t here. You're only plugging it in for that boundary. 7.85. And that is 1,039.356. And then we're going to do 23.6. The next x value we're going to test. So you highlight, go over, change your boundary, 23.6, and that is 842. I'm going to be thorough and write this out every time. If you don't have time and you just write out one, I think they would know that you know what you're doing. But if you have the time, the more work you can show, the better, but don't waste your time if you need to go do other stuff. 842.408. Next one would be 1,000 plus the integral from 0 to 0. What do we know about that? We could do this one in our head. 0 to 0. The boundaries are the same. It's just 0. So that's just 1,000. Right? When no time has passed, you start with 1,000. And then 31. So change your boundary to 31. Oops. I don't know what I was doing. And it's 964.335. So what did our question ask for? To the nearest whole number, what is the maximum for the interval? So the maximum is the largest, which would be right here. And it didn't say where, so we don't want the x value, we want the maximum, which is the y value. So we would just write out, and it said round it to the nearest whole number, so the max number of mosquitoes for the interval 0 to 31 is 1,039 mosquitoes. And that is everything you would need to show for that one. I guess I should put this here one last time if you need to pause it and see anything. Well, I can't scroll out high enough. Well, I guess I'm just going to be rewinding the video because I can't get it to show everything. But hopefully that helped. Let me know if you have any questions.